So we're back at this worksheet. We're going to finish naming. The rest of the molecules on here are esters. I have kind of grayed out the names that we've already used for the carboxylic acids, and so what we are left with are the esters, and this is going to be tricky. This is not going to be easy. So the first thing that we have to do in our rules is to pretend like our ester is a carboxylic acid. So that means we're going to pretend like this isn't here, and we're going to pretend like it's just a carboxylic acid. And we're going to name it like it was a carboxylic acid. 1, 2, 3, 4, 5. So this has 2 substituents, 4-bromo and a 3-methyl. 4-bromo, 3-methyl. How many carbons are in that chain? 5. That makes it a pentane. We're still pretending like it's a carboxylic acid. So pentanoic acid, that's its carboxylic acid name. Now we stop pretending like it's a carboxylic acid and we pay attention to the fact that it's actually an ester. So that means we're going to drop the ic acid off of its name. We're going to replace it with 8. And we are going to name the R group based on how many carbons there are. 3 carbons is propane, or propyl in this case. That comes in front, so we get propyl, 4-bromo 3-methyl pentanoate, which is I. That's tough. That's really hard to do. There's a lot of steps there. Let's see if we can figure out an easier way to, if all we're doing is matching, if your goal is just simply matching, like I'm not going to give you a molecule and say, just come up with this name all by yourself. If your job is to match, then let's try to figure out an easier way to match. So one thing that you can do when you're matching names is recognize that this R group that's attached to the oxygen, that's always going to be the first thing in the molecule's name. Like this R group is just a methyl. So this ester's name is going to start with the word methyl. Let's see if we have any options for that. D starts with cyclohexyl, F starts with ethyl, G starts with heptyl, H is the only option that we have that starts with methyl. So it has to be that. That's it. And that's its name. For sure. Let's move on. Let's try another one. So again, let's use that trick again. Here's our R group. How many carbons are there? 1, 2, 3, 4, 5, 6, 7. That is a heptane or a heptyl. And let's look back and see. Well, there's only one that has a heptyl as an option, but let's pretend like there was more than one. Let's pretend like we couldn't figure just that from the name. So what could we look at next? The next thing that we could look at is the part of the molecule that resembles a carboxylic acid. This is just a 1-carbon carboxylic acid. So the second part of the molecule's name should have meth in it. Like if it was a carboxylic acid, we would call it methanoic acid. But since it is not a carboxylic acid, we're going to be calling it methanoate. So let's look for something that has methanoate in the name. And they're heptyl methanoate. So this is definitely G. So there are ways that we can do this that don't require you to go through all of the steps. For this one, if we were looking for a fast name, the name is going to start, the molecule's name is going to start with, this one starts with ethyl because it has that 2-carbon group. This molecule's name, look at that beautiful thing, a 6-carbon cyclic. That is cyclohexyl. We can probably find the cyclohexyl very easy. Right there. That's D. Cyclohexyl ethanoate. Does ethanoate make sense? Well, that's a 2-carbon parent chain. So yeah, this part would be ethanoic acid, ethanoate, whatever, ethane. This is a 1, 2, 3, 4 carbon. So this part of the molecule would be a butane, a butanoic acid, a butanoate, F, ethyl butanoate.